Hello everyone, my name is Mark and my presentation for today is to talk about a solution that should give auto repairs more time repairing cars and less time researching. Because having a lot of different type of cars and handling complex cars issues will from time to time require some kind of research, like reading a book or talk to someone, which means it takes focus away from actually repairing cars and instead doing research. And result is less time repairing cars and more time doing research, which should be the other way around, right? So wouldn't it give auto repairs more time repairing cars if we put a rack system on top of the research? So the only thing auto repairs has to do is ask questions and receive back answers. And also perhaps have a system that gives suggestions on car parts availability and reasoning on when to order these parts. So those were my two leading questions, which led me to the next part, which is the rack system. So we take our repairs question and pass it into a betting, which then returns back a bunch of numbers, as you see. We then use these bunch of numbers to retrieve documents that are closest to our question. So where do we get the documents? From a vector store, which is where I store the auto repair documents. So we search the vector store, and the vector store will then retrieve back the documents closest related to the auto repair question. Documents we get back from the vector store is then passed together with auto repair questions and instructions such as you're a car specialist and can only provide your answers from the context into a chat model like ChatGPT. And this ChatGPT model will then respond back with an answer. And that is basically how I imagine my solution should work. So basically what I did was converting auto repair research into documents, which are then stored in a vector store, which I will then be used for retrieval. So what I did next was that I took these auto repair documents and split them up in chunks of 400. And chunking is a bit of a science of itself, so I would just say that I use recursive chunking by using LangChain's recursive character text splitter, but I could have chose, for example, semantic chunking. And the reason why I chose recursive character text splitter is that even though it uses fixed chunk size and an overlap, it also looks at different separation characters like double new line. And so far, using recursive characters has been okay for chunking auto repair documents. So I haven't sort of gone to the next level and wanted to use something like semantic embedding. Next, I converted these chunks into embeddings via an embedding model and stored them in a Pinecone vector database space, as you see in the picture here. And by the way, doing testing, I actually asked different questions just to see what documents was retrieved back from the vector store, and I also tried with different chunk sizes and different questions just to see if it gave an improvement to retrievals itself. I then ran the reference documents plus the query through the LLM and then compare the end result. And all I can say is that it gave sort of the same question, the answer, but with different sort of length of the answer. So what I ended up with is basically what you see here in the GIF image. So I ended up making a Teamlet application where the idea is that an auto repair puts in a question related to the auto preparing and then gets back an answer in plain text that should answer the auto repair question. So this was my first iteration of a solution that should give auto repairs more time repairing cars instead of researching. So you might ask, what is the next step? Well, after making the rack, I started validating the rack to see if I could find particular places where it could fail. So I added dataset to Langsmith, and Langsmith is a platform where I can make analysis and monitoring on my rack. For example, I made a validation that checked to see if some of the keywords of a particular question could be found in the response, just to see if the related words was used in the response. So just to put that in a picture, then what you see here is basically the source of running my dataset in Landsmith together with some validating. Here on the left, we have the questions. Then I checked if the word used in the question was part of the output, in part of, well, keywords, so to speak. And the output is represented here on the right. And here you can see what was the response we got back from the chat model. And I used the evaluators like correctness and helpfulness to see how well the response was to the expected result. And that's basically what I did in the iteration, which with, of course, different questions and different chunks of documents, etc. Next, I looked on how I could extend my RAG system with the needs of knowing where can I buy a particular part and how long is the shipping for this particular item. So I sort of draw this graph, which might become the next implementation point for this project. So the idea here was put in a question and the order time for a taillight. And the idea here is basically that should it look up and see if there is some taillight available from a particular manufacturer, or should it just end? End could also be if it, for example, found a manufacturer and availability, or simply, well, didn't find anything and just ended. So that's basically the idea for the next part of my project. And well, folks, that's all I have for today. Thank you so much for listening.